Not yet. Now we are.
Yeah, now.
Okay. Right. Here it is. Happy Bowtie Friday. I'm here with Adam. We are going to look at an Optimism Dapp starter kit. Basically, let's just dive into it. How about that? So I'm going to share my screen. We're going to look at boom. So we have scaffold-eth. You and I in a great community have put together this really cool Dapp toolkit. It's just like a freestanding Dapp that you can get in and tinker with your smart contract, tinker with your front end, lots of good examples, lots of good challenges. And then the Optimism crew came out with this Optimism integration repo, which is basically like a Docker container that brings up like L1 and L2 and bridges and everything like that. Is that right? Do you want to add some color to that before I go on?
Yeah. So this is, I guess, the big picture is we're trying to get like a local environment stood up for Optimism, just to make it easy for us to build stuff, maybe other people to build stuff. Obviously, you can't just run like a local chain because you need a roll up, and it's not just like we've done some stuff before where we've been running like a side chain and local chain. They've been talking, but obviously with the roll up, it's a bit different because then it's actually like on top of the main chain itself. And so fortunately, there is this Optimism integration thing which lets you sort of stand it up all in one go. So yeah, but like as a starter thing, we sort of pulled this into one of the branches, scaffold-eth branches, just as submodules. So effectively, if you pull down that branch and initiate the submodule, then you can essentially stand the thing up from within scaffold-eth.
And that's what we're going to do right here. So you've written an article about it also, and we'll put the article in the notes. But let's just get started with you can go to code here and you can really you walk them through kind of the mental model of what's going on here and some of the gotchas. And I think that we'll leave that to the reader. We'll kind of pick up a little bit of that stuff. But what we're going to do is just start right in this local Optimism branch of scaffold-eth. If you just go to scaffold-eth and look for local Optimism, there it is. And this should be Optimism locally with everything stood up. So we start by cloning it down and yarn install and yarn start. I've saved us some time on that just because it takes a little while, but I do want to do this one manually. I want to bring up the Optimism side and the doc. Is it one Docker container with 6 things or 6 Docker containers?
I think it's one. It's 6 Docker containers, but all under one sort of Docker Compose thing. So you get a bunch of them standing up in one terminal.
Okay, here we go. So the first thing we're going to do is init that submodule, like you said. We're going to update that submodule, which I think just does like a git pull and pulls in any code.
Yes, I think you've done it. You've probably done it on this repo already. So
looks like it's already failing. Yep.
Yeah.
And then make up, right? And this makes the whole rocket launch.
Yeah, pretty much, yes. And it kind of gives you the sort of step-by-step. So you can see all the stuff that's happening now is that you've got like L1 chain, which is like your base level chain. And currently what's happening is a load of the sort of Optimism contracts are being deployed on top of it. And then you've got these other layers, which are all, you can see they're sort of waiting for stuff to be done. And then once all the contracts are deployed, once the L1 chain is done, then the sort of bridging stuff stands up. And then the last thing that stands up, I think, is the L2 sort of roll up, the optimistic roll up.
Awesome. Okay, so now, it's time to, I think it's ready to go. Can we, what do we see in the front end if we try to open it up? We do see a front end, okay, but our contracts aren't deployed yet. Is that right? So we need to do one more command here.
Yeah, although we could.
So I guess
even from just now, like in the app, there are a couple of things you can already do. Because just in the
here, okay,
yeah. So like we tried to make it like sort of comparable to scaffold-eth, like just regular setup, but obviously the different things you've got to be not just looking at one chain, but you're looking at 2 chains. And so you've got these two balances up here. The local faucet is there in the bottom left. That's pointing at the L1 chain. So if you drop your address some ETH, then it'll drop you ETH just like a regular local node. You can see that sort of lands there. And then the first thing we kind of did, which you kind of get off the bat, is just this optimistic ETH bridge. So this is moving ETH from L1 to L2. It's like a little hopefully encapsulated component, and all being well, that'll bridge. So you can see it jumped across, and you could go backwards again. So that's like a little thing where there's a couple of things to be aware of there. Like it's on L2, actually ETH is just it's just an ERC20 contract, so it's a bit of a different mental model. But I know that they're also making some changes to make it feel a bit more like native ETH as well.
That's probably one of our first gotchas to talk through this is you don't have native ETH. If you have a payable function or you have anything in your smart contract that's accepting native ETH, you've got to carve that out and you've got to look at, can I make this an ERC20? Can I make some tricks happen here so I'm not using native ETH? Which means you don't get like the fun hooks and stuff like that that you get from a payable contract where it has that receive function, right? Your change, yeah, your UX will change a little bit. You'll have to have some approve patterns, but with Optimism, it should be approve and transfer very quickly, right?
Yeah, and that one I think they are also going to be adding it so it feels more like native ETH, so that some of those things do hook in. But right now, I think we're having to sort of treat it like an ERC20.
Okay, so now we need to get into our folder. We need to create, okay, so one thing is the local chain is not our usual hard hat chain. They've got a geth instance running in here. So we're gonna have to do a yarn generate right out of the bat. And what that does is just create a local mnemonic and gives us a deployer account. Now, I think I'm gonna take this deployer account and I'm gonna move into the front end and send that deployer like 1 ETH. So they have plenty, whoa, come back here. So they have plenty of money to, there we go. Okay. That's a lot. That's plenty. Yeah. Yep. And then we just deploy OE, right? Here we go.
Yeah, so I guess that's, and again, one thing to call out currently on like local test nets and also on the Koban instance is that there's no gas fee, like there's no gas cost, like you can get free transactions on L2. So that transaction Austin just made was to just the L1 chain because everything's free on L2 right now.
So just to give me a little bit of balance on the geth node, I actually don't need a balance to deploy contracts right now on L2, just to dig into that a little bit more. Yeah, okay. And we'll see that here when we bring up 2 users, they can kind of interact with our contract without having gas, which is interesting. And is it always going to be like that, or is that they'll build that in eventually?
Yeah, so I think there'll be gas fees. If you jump back to the console, you can kind of see what we've just done here because we've done a bunch of stuff, I guess. And you can actually see it from here. So you can see in the logs that first contract is just getting deployed on L2. And you can see it didn't cost anything to deploy. Whereas on then the first ERC20, which would have one we could talk about all this stuff, like cost a little bit, and then so you can kind of see that pattern. And the thing we've done here, just beneath, which is basically just taking that ERC20 that we've deployed, depositing it to L2, and then bringing it back to L1. So it's kind of like a deploy script, also a little end-to-end like test like all at the same time.
You have a demo equals true here inside that OE deploy script. And if demo is true, it goes through that full bridge demonstration.
Yeah.
Dope. Okay, so now what's interesting though for a smart contract dev or a decentralized application builder is we have our contract here. And it's playing by the rules of Optimism, but locally. And this helps us set up like what are we going to be able to get away with? What's it going to feel like? How's it going to work on Optimism? And this is kind of the important part is now can I turn the demo off so I can tighten up the dev loop a little bit? So if I want to, what's that?
Yeah. So if you just go and you can.
There we go. So I'm going to add some more exclamation points. So here's my contract. We have a simple purpose in here. Timestamp we should look at, right? We want to kind of play around with timestamps because the block.hash and the block.timestamp are going to be different because you're probably talking about the L1 block.timestamp. I don't know. I'm excited to get in here and kind of just like test my assumptions. But now we should deploy our contract and this should reload. We should get a fresh contract over here with our extra exclamation points. And then a user could also say hello and change that purpose. And man, that is fast. Okay, cool. So timestamps are one interesting thing to look at, right? Maybe we should look at that first. What is the timestamp?
Yeah, so I guess the only other thing I'd call out, which folks should be like, or that is like potentially gotchas, is that it doesn't just use a regular compiler. One of the things that's happening differently is contracts have to be like specially compiled to deploy on Optimism, and it's been it's been done in such a way that it's pretty seamless. If you go back to the console, like I think on like you can see that compiling one file is 0.17.6 just above, like, and then with the OVM compiler, so essentially there are two compilations happening like going on. And you can turn the OVM compilation off if you like, but like as a general rule, it's good to check that stuff works on L1 and compiles on L1 first, because you might have just made some dumb mistake that's not even related to Optimism. I certainly did, but then you'll also get some specific errors getting thrown if you've got like a call to balance or something that's not supported in the OVM. So yeah, essentially when you're deploying to Optimism, you're using differently compiled stuff, and you're also using a variant of ethers that's a bit different. And so I've got this, like in this repo, there's like a wrapper function which basically lets you sort of say if you want to deploy to the OVM or not, or it, and so yeah, so there's a bit of sort of handling. It's not quite as simple as just pointing at a different different RPC, but it's pretty close.
Awesome. Yep, I see this OVM true versus OVM false here in the deploy. So we're deploying our contract to which RPC we're going to, and you can sell it. You've got L1 RPC and L2 RPC, and then just OVM whether or not it's true, and then like contract args, right? Very, very cool. Okay, so I noticed that I keep going back to timestamps. I don't know why I'm hung up on the timestamp idea, but basically the block.timestamp is not changing as I'm updating stuff here, and that's because we need a transaction to happen on L1, right? So if I go here and do this, this would cause L1, and now we get a fresh timestamp?
Not quite. So that's the thing with the heartbeat that we were talking about. Yep. I think where so yeah, if you go back to the smart contract, we've got these this get like terrible labeling, but timestamp and get optimistic time. So the timestamp is just set whenever we set a new purpose, and get optimistic time is just getting is like just a view function that's getting the blocked at timestamp. So we could see those things being out of sync, but like you said, the timestamp's not changing, and the reason for that is that like time on L2 is basically like when you call block.timestamp, there are no blocks on L2. It's referencing time on L1. So you can see that the timestamp's not actually changing. So then there are two things which reset the time. One is if there's like a bridge event. So if you go back to the bridge and send some ETH from L1 to L2, then if you jump across, like, that should all being well.
There it is. And we got a timestamp update too. Yep.
Yeah.
Okay, cool. But going back to this heartbeat thing, what I'm getting the feeling of is you're going to, if you're building a game that requires time or timing or rounds, there sounds like there might be a heartbeat from them, but really all you could set up your own script that hits a contract and writes the current timestamp every 5 to 10 seconds, depending on what that network looks like. Like, I don't know what the network delay looks like or how fast this is actually going to be. I don't know if anybody does, but this is cool that we get to play within the sandbox. So when they're ready, we can just fire this stuff at mainnet. So yeah, so timing. Okay, so I'm gonna stop diving too far into timing. Timing is not that big of a deal. We can write timestamps to it. So no native ETH. So you've got to have that ERC20 built in, and it sounds like the Optimism crew is going to try to make that feel very native still, but it will be on ERC20s. We're compiling with the new compiler, and that means that there's a little bit of overhead. So I'm guessing your contracts need to be a little bit smaller. We've got this timing issue. What other gotchas are we looking out for here? Anything else that comes to mind that kind of tripped you up along the way with building this?
So there's the one thing, and I don't know if it was this or was it, but it was, oh yeah, so like all accounts are actually like smart contract accounts. Like there's an account abstraction. It's not like they're not all like standard EOAs on L1, which means that, like, I think there was a thing where I was using an Open Zeppelin library which expected some kind of interface to, I think, to safe transfer ERC20s, and safe transfer like checks if it's like there's a certain like receiver thing like applied, which, and because the that's not applied. Like everything, like all of my smart transfers were just failing. Regular transfer works fine, but again, that's just a thing where you're interacting. Essentially, when you make your first transaction on Optimism with an EOA, an EOL1, it gets under the hood. The sequencer basically like deploys or like creates this like pseudo smart contract. I'm probably mangling the words there a bit, but you get the idea. Basically, it's just a bit different in that sense too.
Awesome. Okay, so I'm going to switch gears and I'm going to go to the optimistic NFTs next. Is that cool? Or did we finish that up? All right. So now it's sort of like as a contract builder, as a Dapp builder, I'm going to take your template that you've created and I'm going to build kind of an application on top of it and play around with other things. And we have this cool NFT branch going on right now where we're if you go to scaffold-eth and you look up, I think simple NFT example is the best place to start. It kind of takes you through building an NFT, but then there was this cool buyer mints NFT where we set it up so it's counterfactual and it displays a whole gallery and you can click. And then once you click to buy them, you pay the gas to mint them. So what I've done is mix those two together to create some optimistic NFTs. So we're going to go to the optimistic NFTs branch, and I think I already cloned it down and CD'd in, but let's just do a yarn install just in case, kind of just run through this stuff, yarn start. Okay, and then we do the usual fire up the spaceship, the Docker container probably from Kelvin, right? Fire up Kelvin's spaceship. Let's see here. Let's see. So I need the instructions. I have to copy and paste. So we have to go into that Docker that Optimism integration, initialize the submodule, double check that we've got it updated, and then do the makeup. Boom. Okay, so we've got our front end up. Our back end, it looks like it had to trash some containers. Lots of colors going on here, but I think that's all going to come up. Okay, so now, oh yeah, and I've got the gotcha here, and the total hack where if you want to bring in an NFT contract into Optimism, and that's why we're doing this. This is so cool to run into this kind of stuff. There's one file in the Open Zeppelin stuff that it inherits, this address utility file. And it has a payable address in it. And that one piece breaks like your whole, like all 16 files it takes from Open Zeppelin to make an NFT. This one file breaks your ability to go to Optimism. So we are going to just straight up edit this file. I want to show it breaking first though. Okay, there we go. Now we have it all installed. Now if I do a yarn compile, hopefully we should see that it fails on those two files. There we go. Okay, there we go. So line 54 and 115, and it's right here in the, where is it? Right here. We want to edit this dude right here, this one address.sol file. Let's edit that directly, and here it is. Okay, and we have line 54. I'm just going to blindly comment it out. And line 115, blindly comment it out. Hadrian is out there. I saw he was the last one to commit to this stuff over in Open Zeppelin, and he's probably he got goosebumps on the back of his neck from me doing that. But here we go. Okay, so now we should be able to yarn compile without, and if we want to look at those lines a little closer, they're doing an address this dot balance. They're doing a dot balance on the smart contract, and it won't have a balance because it doesn't have native ETH, and so the compiler throws an error there. But now we were able to compile with those two lines commented out, and we're ready to go. Were you saying something there? What do you think? How are we doing here?
That's the one. I think.
Okay.
There's no balance.
So we have our Optimistic ETH set up. We have our NFT compiling on the Optimism compiler. We're ready to deploy. But the way I've set this up is the artist gets into this artwork.json file. So the artwork.json file is just the kind of the JSON manifest that goes with the NFTs. So I've defined all my NFTs here, including like attributes with googly eyes and stamina. But I've put all of my pieces of art here. So we need to run, once the artwork is good, you need to run a yarn upload. And this is in the the next thing in the README. You just follow the README, right? So what have we done so far? We did the install, we did the start, we brought up the Docker containers, we brought up our local Optimism. Then we kind of compiled our contracts after we hacked those 2 lines. We edit our artwork.json. Now we've uploaded all of our artwork to IPFS, and that gives us back these fingerprints. And what we're going to do is we're going to load those fingerprints into our contract. If we go look at your collectible.sol, the constructor just takes in all these fingerprints and then says, these are legal to buy. And then a buyer can come along and hit buy. And if it's legal to buy, they can purchase that NFT and they pay the gas. The buyer pays the gas. Okay, so we are almost there. We need a yarn generate. And that's when, yes, please.
I guess the cool thing to say is, because I think you had this branch separately, and like to bring this into Optimism, you can pretty much just like bring across pretty much everything, right?
Yep. I took your starter pack. I copied in my contracts. I got that one weird compilation error where I needed to take it out of that address file. And then I was just bringing in components like React components and stuff. Like that was the integration. Okay. So we've got our front end app almost coming up. We're almost there. What we need to do is deploy our Optimistic NFTs, or basically deploy the one NFT contract, our collectible contract. And that deploy script is the same. It's this OE deploy. And we do our deployment. Let's see, right. Oh, here. So I'm going to load the assets up. And then I'm going to deploy to, there it is. I'm going to deploy my collectible with these legal assets. And this is something that I found is like, it breaks right here and we don't know why. We'll figure out why, but that's why we're doing all of this. We're testing this in the world of Optimism. And for some reason, when I add this 10th bytes 32, everything breaks. But let's get to this and let's do, okay, we've got our art uploaded. We've got our deployment script. I'm going to fund this dude over here at the faucet just in case. Send him an ETH. All right, and now we're ready to deploy, right? Here we go. Let's deploy our NFT to our local Optimism. And let's see if our front end should reload, and we could get in and debug the contracts if we want. Here we go, it's deploying. It's deployed, FA23. Okay, so FA23 is out there. Now our front end is reloading. The rocket is launching. And hopefully there's our gallery of art. Yay. Okay, so if this was mainnet, we would have probably just, we would have changed probably a couple things in this file right here. And we would have gone to mainnet, and it should all work the same when mainnet is ready. And so here is, go, please.
So there is config in there to go to Kovan, to the Kovan Optimism, which we could do that.
Ooh, maybe we should. Okay.
I don't know. Do you want to just because the thing where we were getting the 0x with the node deployed? Do you want like we could have a look at that?
Yes. Yep. Let's say, okay, we've gone down the happy path so far, right? And let me just dive into the happy path a little bit more and show you that, like, okay, so so I've got this guy over here and he has ETH. Oh, he doesn't even have ETH. This is a new chain, and neither does this person here. We have like Pink person. So Pink can buy, let's see, he's gonna buy Zebra and Rhino, and let's see, this dude's gonna buy Godzilla and Buffalo, and you can see that these are now like showing up as bot, and they're coming into our collectibles. And just like, let's copy this dude's address and let's send him the Zebra and hit transfer. Oh, that's so nice. Let's grab this dude's address and send him the Buffalo and hit transfer. And there it goes. There we go. So we have this really nice, like, gasless, and it won't always be gasless. We'll have to do this eventually, right? But we have this really nice user experience where we're moving around these assets and we're playing around in a sandbox that represents or is exactly like what mainnet Optimism will be very, very soon.
Yeah, and like, you obviously very kindly are letting people mint these for free, but if they were like more for sale, you could bridge some stuff across from L1 and then use that to buy it on L2. And so
like if I was a buyer, I could come into this bridge. Well, first of all, I would need thousands of dollars to buy Austin Griffith art. So we better get $1,000. And then I'm gonna bridge in like the whole 0.5, right? Let's bring, come here. Oh, 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 I don't know. I don't know what's going on there. That little guy, I wouldn't worry about that little guy. Okay. So actually I could just hit this 5 times and bring in all 5, right? And pay a bunch of gas. There we go. I think I may have hit the bridge too hard. Okay, now I have plenty of money. Now I could go back to this gallery and yeah, we could even like sell them on a curb or do something really neat. But yeah, you could pay $100 right there and your money would come through. Awesome. Okay, now let's break it, right? We've done the happy path. We've seen it. Let's see what happens when you're experimenting with a contract and you break something. So what I found was it was silently failing when I put in all of this art. So let's just bring in all the art and let's do another deploy. Ooh, one thing we're checking here is this debug contracts. There's our FA23. That's something we're watching closely. We're making sure this FA23 changes. So there we've got, it says that we've deployed our contract to 8867. So we're assuming that everything is fine. And here it is, I guess, at 8867. And if I check some balance and make a call against it, yeah, it's like, whoa, 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 I can't check balance of, because this thing doesn't actually exist, right? So our front end has been tricked into thinking this contract is actually deployed, but then we have this nice little check bytecode button we've added in here. And I think you added it into the, oh, I need to inspect here. You added it into our deploy script, so we'll go look at it in a different way. But basically, we hit check bytecode here and we're not getting anything back. There's no actual bytecode at that address. And so let's see, how can we test that in the deploy script now, right? I think you said you wrote something in here that we could, let's see.
Yes, this is kind of this weird one where we were just seeing.
Oh, it's in the other code.
Yeah, it's in the utils. Sorry, in the. I think it should be. Yeah, so I don't know if it'll be in here yet if it wasn't pulled across, but you could actually, if you jump
grab it from the front end.
Yeah, grab it from the front end.
So there's a check code function here. Let's bring that into our deploy or utils.
Utils, I think.
Okay, and this is so when it deploys. Okay, I got it right here. So it's going to wait for that to be done. And then what we're going to do is checking to be sure, right? And we're going to actually take the address that it was deployed to, and we're going to check to make sure there's actual bytecode there, right? And we'll await that. And for people watching at home, we will have this built in by the time they see it, right? Like we'll have this bytecode check. Okay, now let's see what happens. See if I even have the syntax correctly. Okay, there we go. There we go. Oh no, what did I do? L2 provider. Oh
yeah, it's the difference. So if you call it
signer provider, I think.
Optimistic provider, I think, is the one you want. That guy okay. There.
And that goes in here, right?
Yeah.
Kind of doing this on the fly here. Let's see what happens. Bytecode undefined. There we go. So what we want to do is if not result or something like this, right?
Oh, actually, wait. Well, yeah, you'll want to return the code. Sorry, on the check code thing, if that makes sense.
Oh, here. Got it.
Yeah, return that guy.
Oh, so I don't even need to await, do I? Oh, yeah, I do. Let's just, okay, here we go. Come on now. Oh, and now I have if not result.
It's going to have a bad time.
There we go. I can hear my cat snoring. Kitty.
Better than my dog barking.
Oh, where's the const? I've got a. Oh. It's something down here. I'm missing a. Oh man. Oh, weird. Okay. Result 0x. Okay. So 0, we're going to say if result equals 0x, then we've got a problem, right?
Yeah.
Maybe a warning. Ooh, yeah, something like that. Maybe even like break, right? Wait,
Yeah.
return? What am I doing? I'm just like randomly changing the deploy script. Who knows if this thing even deploys? I didn't even look. Contract did not deploy. All right,
Yeah,
cool. Now we've got our safety check in there. So then if I go back to our deploy and I go /star// so for some reason we have a smaller amount of bytes 32 that we're passing into that constructor. I do believe the contract does deploy. Yeah, we didn't get the error there.
Yeah.
Checking to be sure. We can probably take that out. And we'll do a better job. But you watching at home, this thing is evolving quickly, but on your version, we will probably just throw an error here and let you know that the contract didn't deploy. So you don't get out here and try to check a balance and have it fail. This should work now, right? Weird.
Yeah.
Oh, maybe we're doing something. Okay. But let's see. Can I mint this buffalo? Yes, it's actually a bison too. Dope. Okay, I think that's about it. I think we got it covered. I think that's and there we go. You can kind of see the demo here. So let's see. So local is what you're looking for here. You go to local optimism in the scaffold-eth branches, or you go to Optimistic NFTs. Those are the two repos we covered here, and then also your wonderful Medium article. Any closing thoughts or anything else to look at?
No, I think that's a bunch of it. Like I think there's some stuff with the ERC20 bridging. I think bridging is cool. Obviously, we've not got the time lags and those kind of stuff. Like the DAI guys had their cool thing with the instant bridge this week, so it's cool to see.
We should have a DAI contract, right, on Optimism soon. Yeah. Cool.
Yeah, and so it's cool to see all of that.
And were you saying that this setup is basically ready to go for someone else who wants to bridge an NFT in, or wants to bridge an ERC20 into Optimism, or is that not true?
So pretty much picked up, like there are a couple of the core Optimism contracts which are set up to facilitate that. I know there are some discussions on whether there should just be like one uni bridge ideally that everyone used. So you don't have like loads of different like contracts that all mean the same token, that kind of nonsense.
We've got that going on in some other side chains, don't we?
Exactly. But yeah, it's I don't know, I just love making transaction in one place and seeing it happen on a roll up or a side chain. It's cool stuff.
How about the weird collision oracle thing? So we're thinking about making a game. Imagine first of all, like when you're thinking of OVM, it's pretty real time, right? These transactions, it's basically the time it takes to get across the network and get to the magic verifiers. I don't know what's going on underneath the sheets, but I do know that it's like it feels mostly network bound to interface with Optimism, and I don't know if it's always going to be like that. But we're thinking of a game that's more like kind of things moving around. You can imagine there was a rock paper scissors demo that's really good, where like you have these agents that land in the world. They're either a rock, a paper, or a scissors, and they have a random trajectory, right? So given a starting point and a starting time and a trajectory where they are at any given time. So we can kind of just like do one transaction and that causes them to move. Now we can set another transaction and turn them or something like that. But let's say they're just all moving in the world. Eventually they're going to run into each other. And what we need to have is a collision oracle that says, hey, these two just collided, right? You would have someone watching off chain and making a transaction to Optimism anytime these things run into each other. And a collision oracle would say, hey, these things are close enough, cause a collision. And the contract would say, are they close enough given those trajectories? And if so, then we do a collision in solidity. You know, if it's rock, then it beats scissors. If it's paper, it beats rock, right? Then we turn both of them into the winner, and then we set them off on a random trajectory going somewhere else. I think we could totally do that. I don't know what the limitations would be. It sounds like something fun to do. Maybe we'll do that for our next Bowtie Friday build.
Yeah, for sure. There's, yeah, I think, and there's the thing I think I said in the article. There's like different mindsets. I think probably when if you're trying to build something that's on L1 and L2, that like you need to think about how those two things work together, making sure people are on the right network, that kind of stuff. But then there's also just a spot where you're like, let's just go hang out on Optimism, create cool stuff there that's faster, cheaper, all that kind of jazz, which is like a lot of the reason, like a lot of the benefits of like Nifty Inc being on Xstar is because of the speed and the so yeah, I can see people just
We need to be
out,
able to ramp people directly into the L2s though. That's a tricky thing, right? That'll be a lot of fun with some of these games is you just land, you borrow a penny in L2 and then you can just kind of make transactions and play around quick and fast and cheap. Awesome. Optimism on scaffold ETH. Happy bow tie Friday. Thank you, Adam. See you.